Welcome to a webcast produced by the Learning Enhancement team in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Numeracy series and concerns cancelling down fractions. This guide aims to help you understand when and how to cancel down a fraction. This guide shows techniques which explain how it is done. Introduction. When carrying out calculations involving fractions, it is very common to have to cancel down an equivalent fraction to give its simplest form. In fact, one of the best ways you can improve your numeracy is to learn how to cancel down a fraction. For example, cancelling down a fraction is the best way of simplifying long division. Cancelling down and cancelling out. One of the common misunderstandings in mathematics comes from using the word cancel. When you say two pieces of mathematics cancel, you need to distinguish between whether they are cancelling down or cancelling out. Cancelling down is associated with division. The result of cancelling down is 1, never 0. For example, 3 divided by 3 has a 3 on the top and the bottom of the fraction, which can be cancelled down. This gives 1 divided by 1, which equals 1. You can say that 3 divided by 3 has cancelled down to give 1. Cancelling out is associated with subtraction. The result of cancelling out is 0. For example, 3 subtract 3 is 0. You can say that the 3's have cancelled out. So, when you are cancelling, you should state whether you are cancelling down or cancelling out. The idea of cancelling down is also fundamental in algebra and is discussed in more detail in the study guides Simple Factorisation and Multiplying and Dividing Algebraic Fractions. Strategies for cancelling down fractions. To cancel down a fraction, you need to factorise both the numerator and the denominator of your fraction. There are different ways of factorising numbers. You can break each number down into their prime factors. See study guide Prime Factors. You can find the highest common factor of the numerator and denominator. See study guide Highest Common Factor. Or you can identify any factor which is shared by the numerator and denominator. Once you have factorised your fraction, you can then cancel down any numbers which appear in both the numerator and denominator, as any number divided by itself is 1. The 1 does not disappear. It is still multiplied by the remaining factors, but is not shown as any number multiplied by 1 is itself. This idea is important in mathematics, and its misunderstanding can lead to difficulties when studying algebra. Importantly, you can only cancel down if your numerator and denominator are factorised, i.e., they comprise terms which are multiplied together. Cancelling down using the highest common factor, HCF. The most efficient way of cancelling down a fraction involves identifying the highest common factor, HCF, of the numerator and denominator of that fraction. Once you have found the highest common factor, you express the numerator and denominator as multiples of the highest common factor. Example. Simplify 36 over 48. The highest common factor of 36 and 48 is HCF 36/48 equals 12. You now express the numerator and denominator as multiples of 12. So, 36 equals 3 times 12 and 48 equals 4 times 12. So, 36 divided by 48 equals 3 multiplied by 12 divided by 4 multiplied by 12. As you can see, 12 is present in both the numerator and denominator, and so they can be cancelled down to give 1. 36 over 48 equals 3 times 12 divided by 4 times 12. Cancelling the 12s, gives 3 multiplied by 1 divided by 4 multiplied by 1, which equals 3/4. As you have used the highest common factor, you cannot cancel down any further, and so the simplest form of 36 over 48 is 3/4. Other methods of cancelling down. As the highest common factor of the numerator and denominator of a fraction is not always obvious, you can find any number which is a common factor to cancel down. This method may not always give the simplest form immediately, but has the advantage of reducing the size of both the numerator and denominator so that it is easier to identify any further factors. For example, if they are both even, they have a common factor of 2. If you are not confident finding the highest common factor, you should use this method. The study guide, Rules for Dividing Whole Numbers, gives details on how to determine whether smaller numbers are factors of larger numbers. Did I say that right? Yeah, does that sound okay?
Yep.
Okay.
God, I'm concentrating so hard.
Are you? We did this in the summer with all the windows shut and it was like 40 degrees in my office. Another way of cancelling down is by breaking the numerator and denominator down into their prime factor form. See study guide, Prime Factors. The advantage of this method is that once you have your numerator and denominator in prime factor form, you can cancel down all the common factors at once to give the simplest form. As with all mathematical skills, factorisation of numbers requires you to practice. The more examples you attempt, the better you will get at identifying common factors quickly. You can either prime factorise 66 and 96, or look for a factor which is common to both. In prime factor form, 66 equals 2 multiplied by 3 multiplied by 11, and 96 equals 2 multiplied by 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 3. So, after writing the numerator and denominator in prime factor form and cancelling down, you should find that 66 over 96 equals 2 multiplied by 3 multiplied by 11 divided by 2 multiplied 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 by 3. There is a common factor of 2 and 3 in both the numerator and denominator, and these can be cancelled down. This equals 1 multiplied by 1 multiplied by 11 divided by 1 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 1, which equals 11 over 16. Alternatively, as the numerator and denominator are even, you have a common factor of 2. So, 66 divided by 96 equals 2 multiplied by 33 divided by 2 multiplied by 48. You can cancel down the 2's to give 33 divided by 48. Both 33 and 48 have a factor of 3, as their digits sum to a number which is divisible by 3, giving 66 over 96 equals 33 over 48 from before, which equals 3 multiplied by 11 divided by 3 multiplied by 16. You can cancel down the 3's to give 11 over 16, as before. Further guidance and information. If you have any further questions about numeracy or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students Office at the University of East Anglia.